Solutions are called homogeneous mixtures because they are evenly distributed and appear as one complete phase. But how can we explain what happens in some of these mixtures when two phases start to become evident?
In this image, indicated by the red circle, is a mixture between two solutions creating pink precipitate.
Solutions are classified as either unsaturated and saturated. Unsaturated solutions are still capable of dissolving more of a solute at a given temperature, whereas saturated ones are not. And if more salt is added to saturated solutions, knowing that it can no longer dissolve any more than what's already in the mixture, this particle will eventually settle down at the bottom, forming a solid phase.
What is precipitation? It is a solid substance formed after a chemical reaction between two solutions or salts. The process in which precipitation forms is quite simple actually.
Precipitate. This is the solid that is formed when two liquids or aqueous solutions react. It occurs when the concentration of a solution is already above its solubility limit. Solubility being the amount of a substance that can be dissolved in a given amount of solvent.
First of all, you will need to mix two salts together, shown in the second tube. In the third tube, supersaturation will then occur. After the saturation happens, you will start to see the precipitation forming in clusters, thus leading to the fifth tube with the precipitation set at the bottom of it. As for the last tube, you may then remove the precipitation for observation.
Now, although we know how it is formed, how do we know what is formed? An experiment about these pairs of solutions reacting together is used to determine how the name and formula of each precipitate is obtained. Balanced molecular equations of these solutions are first written down, and now we analyze the products. In the first molecular equation, potassium nitrate is one of the products. According to the solubility of common compounds, nitrate will always form a soluble substance with any positive ion or metal. Therefore, all the other products with the nitrate is soluble and is not a precipitate. Moving on, barium chloride is also soluble according to the previous chart. Therefore, all barium chlorides in the molecular equations are soluble. Potassium chloride, potassium carbonate, sodium chloride, and sodium carbonate are again, according to the previous chart, all soluble products. What's left is the barium carbonate, which, if checked in the previous chart, is insoluble this time. The only precipitate formed is therefore barium carbonate, which gives us this net ionic equation. The net ionic equation only involves the precipitate or the solid substance and its ions, compared to the molecular equation, which includes all the molecules in a solution. All the other mixtures in set 1 are clear, except of course with the mixtures of sodium carbonate to barium nitrate and sodium carbonate to barium chloride, which are cloudy because of the precipitate formed. The second set of molecular equations has the same method of determining the precipitate. As mentioned earlier, any product which has the nitrate as the anion is soluble. So is sodium chloride and barium chloride. However, in the case of sulfate as the anion, it is never soluble when the cation is either barium or strontium. Therefore, they are precipitates. And finally, according to the chart yet again, chlorine is soluble with either aluminum or strontium, and the sulfate with either aluminum or sodium. In this set, the precipitate consists of barium sulfate and strontium sulfate. They produce cloudy mixtures while the rest produce clear ones. Too much solute in a saturated solution continue to dissolve and crystallize, which proves such solution to be in equilibrium. In its nature, if you are not a part of the solution, you are part of the precipitate.